So the first thing we should do, we're looking for the net force acting on the 3 microcoulombs. Well, actually, conceptually, what direction do you think this plus 3 is going to move? If this was allowed to move, what direction would it move?
East. Up to the right.
All right, so let's think about it. Let's maybe put it step by step. If this is a minus and this is a plus, what's the minus going to do to the plus? Attract. So there's going to be a force going this way, a force of attraction. We can call it F63, pulling up. And then there's a plus and a plus. What's the plus going to do to the plus? Repel it. So there's going to be a second force this way. Let's call that F53, pushing it to the right. Okay? So if this were allowed to move, what direction should it move? General direction.
Northeast.
Northeast, right? So it should get pushed up this way because it's repelled and attracted, so it should get pulled up diagonal, right? All right, so that's what we're going to do. We're going to go ahead and try to figure that out. So let's find these forces individually first. And actually, we just found them in the warm-up, but just for the sake of your notes, let's at least write out the equation. So F53, that's going to be the force between these two, right? So that's 9 times 10 to the 9th, 5 times 10 to the negative 6, 3 times 10 to the negative 6, 0.04 squared. And was that the 84 one?
Yeah.
Okay, so this is pushing to the right with 84.4 newtons. And then what about this here? This is going to pull on it. So we'll go ahead and do the same thing. So this is our F63. Again, just for the sake of our notes, let's just do it out. 9 times 10 to the 9th. And again, don't plug in your negatives. So we're just going to plug in 6 and 3. Divide by the distance. So notice in the ones we just did, the ones we're doing here, at this point there's no difference. Was this the 180?
Yeah.
All right. So we're asking for the net force. We just found these two. What do we do now? Do we just add and subtract these? What are we going to do? Make our triangles, right? So we're going to say, oh, it's going at this direction. So we're going to do our vector math. Now be careful. Like a real common thing for people to do is to go just connect the triangle like this. However, think about it conceptually. It doesn't make sense. This, if you connect the triangle, you're basically saying this charge is going to go like that. That doesn't make sense. Or like this. That doesn't make sense. So when you draw your triangles, remember you always go, you draw one out. So let's draw the first one out. This was the 84. And then we go tail to tip. So we're going to draw the second one this way, 180. And now when you connect your hypotenuse, when you draw your hypotenuse, it's in the clear direction. So always go back to the concept, make sure that your triangle is drawn correctly. All right, where do we go from here? You're looking for this, right? So Pythagorean theorem, a squared, b squared, c squared. It's like around 200, right? 1. Okay, we'll just go 199. So is that enough? Is that the final answer? Not quite. What else do we need? Direction, right? Can we just say northeast and we're done? Got to get that angle, right? So we're going to find that angle to get our exact direction. Okay, so tangent of theta equals opposite over adjacent. Make sure you're in degrees mode.
64.88.
Okay, and how do we state this angle? Okay, so our final answer is 199 newtons. That's the magnitude of the force. Our direction would be about 65 degrees north of east.